Hey guys, this is Junaid here from K21 Academy, and I welcome you all to this interesting session where we're going to discuss various important data science questions that can be asked if you're someone who's applying for a job role in a data science, machine learning, or a deep learning place. So without any further ado, let me quickly start off. But guys, before we begin, do consider subscribing to our YouTube channel and hit the bell icon to stay updated on trending technologies. And also, if you're looking for any courses on data science, you can find them in the link below. Alright then guys, so let us now start off by looking into our first question. So starting off with, what are the difference between supervised and unsupervised learning? This is one of the basic questions and it can be asked for anyone, yeah? So it's important for you to know what's the difference between supervised and unsupervised learning. So let us now see what's the answer for this. So as you can see here, supervised and unsupervised learning. So what this answer over here says is that, when you have a supervised learning, you have an output parameter. So when you train a model or when you train a history of data, right? Or the data on which a model is going to be built, you'll have an output that you can look upon or to compare upon. Whereas for an unsupervised learning, the output part is missing. So here we work with various types of clustering methods to see what are the various parameters that meet up. All right. Some of the common examples for supervised learning are going to be linear regression, logistic regression, decision trees, support vector machines, and many more. And some of the popular examples for algorithms for unsupervised learning is going to be k-means clustering, hierarchical clustering, and many more. All right then, guys. So let us move on to our next question. What is cross validation? All right. So as you can see here, right, cross validation is basically a technique which we try to use, when to see how well our model is performing. So what do I mean over here? Okay, let's say you have a data, right? Let's say you're working with a supervised learning algorithm, let's say linear regression. And obviously you have trained your model and you have created your model. Now you want to see how well your model is performing before you can deploy it. So what you're usually going to do is you're going to train, test, and split, right? So what this means is whatever the data set you have, you're going to split that for a training data set and a testing data set. The good way that you can choose over here is take 80% of it which goes for training and 20% of it goes for testing. And based on the values that you get on testing is how your model will perform on the actual environment. So this is why cross validation is important, and also the cross validation score is important. So moving on to our next question, explain confusion matrix. Okay, so let's see what the answer for this. So as you can see here, confusion matrix, right? So there is a matrix which has three parts over here: true positive, false negative, and true negative. We use confusion matrix only when we are trying to use classification problem. Now you might be wondering, when do I use classification problem? Whenever I have a categorical data, let's say you have various parameters and those parameters or features belong to either a cat or a dog. So now your machine learning algorithm is responsible for finding out, to whom does this value belong to. So this is what is called as categorical value. Okay, so when you have categorical value, it can be binary, where it can be either cat, dog, or it can be for n number of classes. So it can be cat, dog, horse, human, multiple stuff. So this is what confusion matrix does. So confusion matrix gives us how many values were truly predicted to be a correct value. Be it like, let's say we have a model and the model has predicted that that it is supposed to be cat and the output is cat. So this is called as true positive, and similarly it goes for the false negative and false positive. This is what happens whenever whenever a model is predicting a value to be wrong. So confusion matrix is a good way to understand how well our model is performing, as it would give me something called as precision and recall. So let us now move on to our next question. What does NLP stand for? Okay, so NLP basically means natural language processing, and it's a branch of machine learning, or you can also say AI, where we are going to process natural language. What do I mean by natural language? Whatever the text that you're speaking, be it English or be it any multilingual language, that is called as natural language processing. And extracting data or creating an application used on natural language, we basically use NLP. Moving on to the next question, why is dimensionality reduction important? All right then. So what is the meaning of dimensionality over here? So dimensionality basically means the features, right? So more the number of features, first off, it's going to be complicated. Apart from that, sometimes some of the features would be irrelevant, and having those features would make our model underfit or overfit. So in order to reduce that, right, we use something called as EDA techniques. EDA basically means exploratory data analytics. And in the EDA technique, if you understand that there's a high correlation, or some data set, some values in a data is irrelevant to my output, or the dependent value or the dependent features, this is where I eradicate those. So this is where dimensionality reduction is important. Once you reduce your data, to give you a better example, let's say you have a cuboid, right, which is a three-dimensional image. Now, it would be easier to analyze this if it was a 2D image. So this is what is dimensionality reduction in data science. Moving on to our next question. Again, similarly on this, what is principal component analysis, right? PCA. Well, PCA is basically an algorithm, and this algorithm is used to reduce the dimensions. Okay, you cannot just randomly remove a value, right? Let's say we have a house price prediction and you might have 4 or 5 values. This is fine. But what if you have 1,000 different parameters? You'll obviously have to see pair plots and see which values are more related or which values are more relevant. So this is where PCA comes into picture. One of the example that I can give here is, reducing it from 3D to a 2D size. So moving on to the next question, we have, why is naive algorithm so bad, and how do we improve a spam filter detection algorithm that uses naive? Okay, so now we are going to take, or moving ahead from the theoretical side. Now we are going into something like we are given a scenario, and now we have to give a justification for that. So we all know, right, the naive Bayes algorithm is basically used for classification of text. So the problem with naive Bayes is that it is strong assumption to the features. Okay, so let's say we have an email, or let's say we have a model which has been trained that fake always means it is a spam mail. But let's say if you are someone who is genuine, right, and you want to use a newer value, like let's say you are a genuine person sending to another genuine person, and when you send an email, right, the spam filter would consider that to be a spam mail. So this is one of the reason why naive Bayes algorithm is having a drawback. So one way to improve this is by having by decreasing the autocorrelation features. Okay, so yeah, so let's move on to the next question. So, do you think 50 small decision trees are better than one large decision tree, and why? Okay, this is a classic example for ensemble technique. If you know ensemble technique, right? Ensemble techniques are basically like multiple machine learning algorithms. You use them to understand what is their output, and then you combine them to give out one generic output. So what happens with 50 decision trees, right? It's just one algorithm, okay? But let's say, and the problem with 50 decision tree is that there is a high chances of overfitting. But now let's say you have a smaller decision trees and you have multiple of them. So each of these decision tree will give you one particular output. And based on the voting or whatever values that you choose, right, whichever probability is high, you'll end up getting that correct value. Therefore, the answer for this is pretty simple. 50 small decision trees are better than one large decision tree. All right then guys, moving on to the next question. Why is mean square error a bad measure for model performance? And what would you do to suggest instead? Okay, so we all know in order to find this, we have two types of error: mean square error and mean absolute error. So what happens with mean square error is that it gives us more heavy errors, right? So let's say if the error is pretty high, it would amplify it up. So therefore, mean square error is not that good when it comes for measuring the model performance. Instead, we can use mean absolute error. All right, then, so moving on to the next question, how to check if the regression model fits the data well? So there are a couple of values that you can use here. First off, we can use R-square values. R-square values ranges from -1 to 1. And if the value of R-square, how much ever it ranges towards 1, it means your model is well. The other option that we have is the F1 score, okay? And then we also use mean absolute error. Moving on to the next question, what is decision tree? You might have seen this, right? We discussed about decision trees some time back. So let's now see what is decision tree. Well, as you can see, decision tree is a popular machine learning model, and this is basically used on something like supervised learning data. Decision trees can be used for both classification and for regression tasks. All right. And now the way decision trees are conducted is like, first off, we have the leaf node. The leaf node is something which doesn't have any further nodes. Okay. And then we have intermediate node, the one in the middle. And then we have the first one that would be the parent node. Moving on to the next question, what is collinearity and what to do with it? Okay. So as you can see here, we have multiple values here. You can see here we have A, B, and C. Yeah. So what happens with collinearity or multicollinearity is all these three have the same features. So what this means, if A increases, B increases, B increases, C increases. So, instead of having A, B, and C, I can just have one. Okay, we can drop out B and C features. That is basically performing dimensionality reduction. So this is what collinearity means. And having, multiple features like which are same doesn't make any sense. So moving on to the next question, what is boosting? Boosting is another ensemble learning techniques. Okay, so boosting makes use of various small classifiers in order to give us one strong classifiers. And boosting can also be used again for both regression and classification task. Fine, then moving on to the next one, difference between convex and non-convex cost function, and what does it mean when the cost function is non-convex? Okay, see, when we are dealing with any supervised learning algorithm, be it for linear regression, be it for logistic regression, random forest, or any algorithm that you have, when we have just a convex function, it means that we have one global minima. Okay, there will be only one point which is the least point. But if a function is not convex, then we'll have multiple global minima. And although there might be one, okay, as you can see, although we might have one global minima, but then algorithm might be stuck if the learning rate is not high, or if the error is not high, the algorithm might be stuck in this local minima over here. Therefore, it is very important for us to have a convex loss function. Moving on to the next question, what is a central limit theorem and why is it important? All right, I'm pretty sure central limit theorem is something that we all have studied in our high school and in our 12th, right? So let's now see what exactly is central limit theorem. So the central limit theorem states that a sampling distribution of simple mean approaches a normal distribution as the sample size gets larger no matter what shape of a population distribution is. So basically what happens over here in central limit theorem is, let's say, as you can see here, we have a distribution here. This is a normal distribution. So when you pass this through a function, right, what happens over here is that you'll have a single global maxima. Okay, and this is how the curve would look like, a Gaussian curve. And the reason why simple limit theorem is important is because we use it for hypothesis testing and to calculate the intervals of the confidence. So moving on to the next question, what is statistical power? Okay, so this is not the power of, like, let's say x square or something. What is statistical power? So statistical power refers to the power of a binary hypothesis, which is probability that test rejects the null hypothesis given that alternative hypothesis is true. So moving on to the next question, how do you handle missing data? What imputation techniques do you recommend? Okay, so yeah, first off, what exactly is missing data, right? So when you receive a data, or when you're a data scientist, and obviously you have to create a model, so you require a huge amount of data. And especially when it's a raw data, it's an ideal condition to have all the values present or something which is perfect. So this is where you have to deal with missing data. So what happens with missing data, right? So if you pass on a missing data, sometimes there will be a null value which will not work with our model. So in order to deal with this, we have a couple of ways. And here are some of the ways, as you can see. First and foremost is, if the number of missing data is small, you can just eradicate it, as it won't make much difference in our model. The other one is we can fill those missing data with mean, median, or mode, which totally depends upon what type of data set you have. Then you can assign a unique value. Let's say wherever we have none value, we want to make it as 0. Or then what we can do is, if the number of missing data is huge, so I can create a machine learning model based on the data that I already have, and then provide the input features for the other ones, and then just predict the values of that. And this is something which is more accurate when you have huge amount of missing data. All right, guys, so moving on to the next question, is mean imputation of a missing data acceptable practice? Why or why not? All right, guys, so basically, as I mentioned earlier in the earlier question, right, one of the ways that you can fill in on the missing data is by dealing with a null value, is by taking a mean, all right, mean, medium, or mode. So here it's saying, is mean a good way to deal with the data? Well, let's see what's the answer, right? So mean imputation is the practice that is replacing null values with the data of a mean. So now the question is it worth it or not? I would say no. Okay, so the reason for this is because, let's say if there is a certain value which is wrong in certain places, so that value would be considered in the missing data. So what I would suggest is, if the data set, or if the value or the number of values that are missing is pretty high, then in that case you should not go with the mean. Instead, you should create a model. So moving on to the next question, how can you avoid overfitting of your model? So to understand what is overfitting, right, so let's take an example, right? So overfitting basically means that our model has learned each and every data set. So on the training data, our model would work absolutely fine. It would even give you 100 plus accuracy. But when you give a testing data or real world data, what happens is model will fail to predict the values. So this is what is overfitting. So there are a couple of ways you can avoid overfitting. First off, as you can see here, we can just keep our model simple. Okay, and this would obviously prevent our model from overfitting. Then make sure you use cross-validation techniques such as k-fold cross-validation. Then also make sure you have regularization techniques such as lasso regularization. This is obviously prevent our model from getting overfitted up. So moving on to the next question, What are recommendation system? I'm pretty sure none of us need an explanation for this. Recommendation system basically means that, if let's say you have searched for headphones a number of times, now, when you're on Amazon, it will basically give you the same products or the products that you have searched upon. So to give you a formal explanation of what is a recommendation system, it is a subclass of information filtering techniques. It helps you predict the perfect or rating which is likely that you would buy it. So moving on to the next question, how can you select K for K means, right? So let's see what gives us the answer here. So K basically is for clustering, right? So clustering over here basically means that the number of clusters you should form, and K is the number of cluster. So if you put 2, that would be 2 clusters, and if you put 5, that would be 5 clusters. So the way that you can do over here is by obviously using an elbow method. You can use elbow method to predict number of Ks, or this other one is with the WSS method, that is sum of square method. This is basically telling us the distance between each member and the centroid of this cluster. So moving on to the next question, what are feature vectors? Okay, so a feature vector is an n-dimension vector of a numerical feature that represents an object. In machine learning, feature vectors are used to represent numeric or a symbolic characteristic of an object. So to give you in simple, right, what is feature vector? So let's say you have a cat and a dog. So what are the features of a cat that you have, right? Let's say 4 legs, then you have a whiskers, a body type, height and all. All these are features. And when you put them in a matrix form, they are called as feature vectors. So moving on to the next question, what is a logistic regression? Okay, so logistic regression, as I mentioned earlier, is a machine learning algorithm. And this is basically, I would say, a modified version of a linear regression. Linear regression, if you all know, is a simple line which is called as a model. When you pass this line through a shortening function, let's say softmax or tanh, so this would turn this into an S-shaped curve. And logistic regression is basically used for performing binary classification. You cannot do multi-class classification with logistic regression. Moving on to the next question, again we have what are recommendation systems? Well, recommendation systems are the subclass of information filtering that are meant to predict the preferences or rating that used to buy a product. Then again, the other part of filtering or the information filtering is what is collaborative filtering, right? So collaborative basically, what it means is to learn from someone else's experience, to deal with something else. So now if you have, like, let's say there's a person who has watched a certain movie and you are her friend or his friend, and if your most of your character match or most of the genre of the movies that you match, obviously it's not bad, right? If I recommend the movies that she sees to you, isn't it? So this is what is collaborative filtering. Collaborative filtering would give me the recommendation about what I like from someone else's experience. This is what is collaborative filtering. Okay, so this is one of the most important questions that will be asked. Do gradient descent methods always converge into a similar point? So let's see what is the answer for this. All right, so gradient descent, we all know we use gradient descent as and then pass that through our loss function, and our agenda over here is to get to a global minima. Okay, so what happens is it's not always necessary that the our point or our model reaches the global minima or the cost function reaches the global minima. So it would not reach a global minima at this, but yes, you can optimize it by by improving the learning rate and various other parameters. All right, so moving on to the next question, what is the goal of A/B testing? All right, so answer for this is a statistical hypothesis testing for randomized experiments with two variables, A and B. The objective of A/B testing is to detect any changes to a web page to maximize or increase the outcome strategy. Moving on to another mathematical question, what is the law of large numbers? Okay, so this basically is a theorem that describes the result of performing the same experiment very frequently. This theorem forms a basic of frequency style. It states that simple mean or simple variance and simple standard deviation covers to what you're trying to estimate. So moving on to the next question, what are confounding variables? All right, so these are the variables in statistical method that are correlated directly or inversely with both dependent and independent values. Okay, so if you don't know what is dependent and independent values are the features or the feature vectors, and dependent values are what you see in the output of it. So whatever the values that we have that relate these two are called as confounding variables. What is selection bias? Selection bias in general is a problem situation in which error is introduced into a non-random population sample. Alright, then moving on to one of the most important question, what is the difference between overfitting and underfitting? Well, underfitting means that your model has not trained. Okay, so no matter, it's so bad that the model will not work fine even for our training data set. As you can see over here, this is a classical example of over underfitting. Moving on to overfitting. Overfitting means that your model has learned all the parameters so well that it performs well on the training dataset, but nothing on the testing dataset. Moving on to the just right model or a good balance model, what happens over here is that we have certain gaps, okay? And here the value will not be exactly similar, but it would be something probabilistically very close to the actual value. So this kind of model is called as a best model or the good balance model. So what is prior probability and likelihood? Prior probability is a portion of dependent variable in the data set, while likelihood is a probability of classifying a given observant in the presence of some other variable. Okay, so what I'm trying to say over here is that prior probability is something that has already occurred, right? And likelihood is, let's say, an event A has occurred, and what is the likelihood that event B will occur provided event A has already occurred. Okay, all right, guys, moving on to the next question. What is prior probability and likelihood? Prior probability is a portion of a dependent variable in the data set, while likelihood is a probability of classifying a given observant in the presence of some other variable. So let me clear what I'm trying to say over here. Prior probability is something like the event that has already occurred, and likelihood basically tells me what's the probability of another event happening provided that an event has already occurred. Okay, so this is one of the basic algorithm that is going to be used in our naive Bayes. Moving on to the next question, name 3 disadvantages of using a linear model. See, the 3 disadvantages of linear model can be something like, first off, the linear model has to comply with the linearity. And apart from that, we cannot use linear model for binary or n number of classes classification. Apart from that, linear regression leads to overfitting problem which cannot be solved. Moving on to the next question, explain collaborative filtering. This is again another type of information filtering techniques. So collaborative filtering used to search for correct patterns by collaborating viewpoints, multiple idea sources, and various agents. Moving on to the next one, what is ensemble learning? I think I have mentioned ensemble learning a number of times over here. So ensemble learning method, or this is like a machine learning method, and this can also be used in deep learning. Here, what we try to do is we are going to use multiple small learners to create one big learner. And this would ensure that the model is perfectly fine. This is usually used to prevent overfitting or underfitting techniques. Alright guys, so let us now move on to the next question. What is regularization and why is it so useful? So before we move on to the answer, right, let me give you a quick disclaimer here. You see, regularization is one of the most important things that has to be performed if you want your model to give a correct results. So what happens in regularization, right? Well, let's see the answer for this. So regularization is a process of adding a tuned parameter to a model to include smoothness in curve in order to prevent overfitting. So what do we understand by this, right? Well, okay, so let me give you this understanding here. So as you can see the curve over here, right? So the blue one over here. So this is when your data is not regularized. So what does this represent? You see, we have various types of data, okay? And every, like, let's say for our independent parameters, right? So we'll have like different values. Let's say for house price prediction, if I take that as an example, then what happens over here is that let's say the age of the house, like it's 25 years old, the value for this is way different from the size of the house. It's going to be the number, right? And as we all know, machine learning will not, like algorithms will not understand the parameters like a centimeter or something. So in order to bring them to a certain value, right, we try to regularize them, and usually we try to divide this by the maximum number which is there in that particular feature. So what happens with this? So with this, what happens is that we get a smoothened curve. And if the curve is smoothened, right, so that means all the parameters will start ranging from 0 to 1. If this is the case, then what happens? Our algorithm will try predicting the values in a more accurate sense. Moving on to the next question, define the term deep learning. Well, you see, deep learning is a subtype of machine learning. It contains algorithm which is kind of resembling to artificial neural networks in our brain. Moving on to the next question, discuss artificial neural networks or ANN. Artificial neural networks are a special set of algorithms that has revolutionized machine learning. It helps us to adapt according to the changes input. So here with artificial neural network, we are inspired by how it works with human brain. Moving on to the next question, what is backpropagation? Backpropagation is essential a neural network training. It is a method of tuning the weights of a neural network depending upon the error rate that is obtained by previous epochs. So basically, deep neural network, you use back propagation to understand or to give a proper prediction outside. Moving on to the next question, which is the best language for data science? Is it going to be R or Python? Well, you see, you can use R, but Python is something which is being used universally. Okay, and if you're someone who is using this for text analysis, Python will provide you more frameworks for text analysis. But R, if you're talking something very specific to text, it does not offer any features or a tool. Moving on to the next question, various types of frameworks that we have for deep learning. All right, so this is something very generic and very important. If you're someone who is using deep learning, right, you might know we use GPUs as well as CPUs. So some of the popular frameworks that we have is TensorFlow, PyTorch, Keras, and Caffe. Apart from that, if you're someone who is not from a coding background, you can also use Azure Machine Learning Platform. A quick fact, guys, if you're someone who is interested in learning more about Azure Machine Learning, you can check out the link on K21Academy.com/DP10002. Moving on to the next question, explain autoencoders. Autoencoders is a part of deep learning algorithm. It helps you transform an input image into a very few number of errors. Okay. After this, we can use autoencoders to reconstruct the same image. Why do I use autoencoders, right? That would be your next question. Well, autoencoders, you can use it to decrease the noise when you're working with deep learning. Apart from that, you can also use autoencoders to compress your image or to see any fraudulent activities that has been happening with your images. Alright guys, so let us now move on to the next question. Explain selection bias. So selection bias is a bias that occurs during a sampling of data. This kind of bias occurs when a sample is not representative of population which is going to be analyzed in a statistical study. So what do I mean over here, right? Okay, so let's say you have like 1,000 records, right? That is 1,000 rows you have in your data set. And like sampling basically means in general to pick something in random, like a small set of value that represents that 1,000 records, right? Now you have sampled your data in such a manner that it has haphazardly taken some random values, right? Obviously sampling is random, but it has taken those values which don't represent this data set. So this is called as selection bias. So in order to do this, we can always increase the randomness, and we can also make sure that our data set is always shuffled before we try to use it. So this is what is selection biased. Moving on to the next question, when underfitting occurs, is it a statistic model? Okay, so as I mentioned earlier, underfitting occurs usually when when the model doesn't work fine. Okay, so if you're using a statistics, right, if you're someone who is using probability, if you're using statistics, then the model comes out fine. But when underfitting occurs, that means that there's something wrong with the loss function or some other parameters. Moving on to the next question, name the commonly used algorithms. So let's see some of the most commonly used algorithms. One of the four most commonly used algorithms by data scientists are linear regression, logistic regression, random forest, KNN, and something else that I would also like to add over here is going to be ensemble techniques. This can be boosting, bagging, and various other algorithms. Moving on to the next one, what is univariate analysis? An analysis which is applied on none attribute at a time known as univariate analysis. Okay, box plot is basically used to understand univariate analysis. Okay, so we basically use univariate analysis to understand none values. Moving on to the next one, explain cluster sampling techniques in data science. Clustering is basically used in unsupervised learning. As I mentioned it earlier, that when you are doing unsupervised learning, this is where you don't have output features. So everything depends upon the clusters or the similarity in the features. So yeah, let's see what is cluster sampling. A cluster sampling method is used when it is challenged to study the target population spread across a simple random sampling, and it can't be applied. Moving on to the next one, what is recall? Okay, so this is a confusion matrix as you have seen earlier. So a recall is a ratio of true positive rate against the actual positive rate, and recall value changes from 0 to 1. Moving on to the last but not least, is it possible to capture a correlation between continuous and a categorical value? And the answer for this is simply yes. We can analyze the values between the continuous and categorical value, and then we can see the correlation between them. Moving on to the next one, treating a categorical variable as a continuous variable would result in a better predictive model. So let's see what's the answer for this. Yes, a categorical value should be considered as a continuous value. With this, it gives us a better prediction. All right, guys, these were some of the questions. Apart from this, something that I would like to give you is, if you're someone who's interested in learning more about deep learning and something especially in Microsoft data science, you can just check out our free class. And the link for this is going to be k21academy.com/dp10002. Alright guys, with this we come to the end of our session. I hope you enjoyed and had to learn something new. If you guys are further interested in this course, I would definitely recommend you to check out our free class over here. And in order for you to opt for this free class, it's pretty simple. All you have to do is go down to k21academy.com/dp10002. Let me show you how you can register yourself over here, and then just type k21academy.com/dp10002 and then hit enter. Okay, and once you're done over here, you can see you are presented with this page where you have Microsoft Azure Data Scientist certification and demo, and here you can just book yourself here. So click on this. We have events at various dates, you can see here, and on various times, so whichever time is convenient for you, so make sure you select that app. So here everything is in Indian Standard Time, so let me select Sunday, and then you can just put here your name, and then finally you can just put email address of your choice and the phone number. Make sure you have selected a correct region over here. So as we are from India, so it's going to be this. You can put down a number and then click on for yes, save my seat. So with this, you'll be given the agenda of that particular session so that you can prepare yourself with that. And apart from that, we have a Zoom link here, which every time you click here, it will log you into the screen. And this is how you can take up your free class and see, whether the data science or the domain of data science is for you, so that you can invest yourself into the course over here. All right guys, with this we come to the end of this session. I hope you enjoyed. Until next time, goodbye and take care.